Hello everybody. So for today's video we're going to be talking about directional derivatives and the gradient vector. So up to this point we have just seen partial derivatives. If those are derivatives in the direction of your x variable, derivatives in the direction of your y variable, or whatever variable you want to deal with. But since it is capable of finding a derivative in a particular direction of one of your variables, if you did some transformations, you'd be able to find your derivative in any other direction you want. And this actually turns out to be fairly straightforward. So if you want to find your derivative in the direction of the vector AB, and this can be extended to 3, 4, 5, however many variables you want, all you have to do is the standard limit definition of your derivative, but instead of just going from adding h to x or y, you're adding h times its component and then adding it to the right variable. So this works out the exact same as most other derivatives. It is slightly uglier to compute, and some of your derivative rules don't work quite as nicely. Thankfully, there's a little bit of a shortcut. So if f is differentiable in terms of both x and y, and your direction is a unit vector, then you can easily write it out as the partial of x of your function multiplied by your x component of your unit vector plus the partial of y multiplied by your y component. So this is a nice simple way to calculate out directional derivatives, so you can find your derivative going in any direction you want. So hopefully that helps you out with that regard. Now, that's your directional derivative. The other thing for this video we're going to be talking about is called the gradient vector. So this one should be pretty straightforward for you guys. So all your gradient vector is, it's a vector with all of your partial derivatives. Just the first terms. There's something later on that we'll be talking about which deals with second derivatives. But for just the gradient vector, we are talking about a vector of each of your partial derivatives with respect to each of the different variables you have. All right, so hopefully this is fairly straightforward to calculate out for you guys, and I'll see you in class.